Hello friends, welcome to EC Academy.
In this lecture, let us understand the influence of beta n by beta p ratio on transfer characteristics of MOSFET. So this is very important concept in VLSI design. So what is beta n by beta p ratio? So here beta n and beta p ratio are the transconductance parameters of NMOS and PMOS. So beta n is the transconductance parameter of NMOS and beta p is the transconductance parameter of PMOS in a CMOS inverter. The ratio beta n by beta p essentially tell us the relative strength or mobility of electrons in case of NMOS compared to relative strength and mobility of holes in case of PMOS. So this ratio plays a very important role in how an inverter behaves, especially in voltage transfer characteristics, which is the relation between the input voltage and output voltage. So beta n and beta p represents the transconductance parameters in case of NMOS. So here beta n represents the transconductance parameter of NMOS and beta p represents the transconductance parameter of PMOS in a CMOS inverter. So here the ratio beta n by beta p will tell us the relative strength or mobility of electrons in NMOS compared to the relative strength or mobility of holes in PMOS. This ratio plays a very important role in how an inverter behaves, especially in voltage transfer characteristics, which is the relationship between the input voltage and output voltage. Now let us understand the voltage transfer characteristics. To understand the behavior of inverter on the basis of beta by n ratio, this figure shows the voltage transfer characteristics of CMOS inverter. Here we have taken different beta n by beta p ratio to understand the behavior of the CMOS inverter. Here the x-axis is the input voltage and y-axis is the output voltage. You can observe here few curves that are shifted based on beta n and beta p ratio. When beta n by beta p is having an higher value like 10 is to 1, the transition from high to low happens at lower input voltage, as you can observe. So the switching has happened for lower input voltage. As this ratio decreases to 1 is to 1, this transition will shift towards right side. We know that the threshold voltage V in is equal to VTH is where the inverter switches from high state to low state, and this point is dependent upon the beta n by beta p ratio. The threshold voltage V in, which will be approximately equal to VTH, varies as beta n by beta p ratio decreases and the transition region moves from left to right as shown in the graph. So from this graph we understood that when the beta n by beta p ratio is high, the transition will happen at lower input. As beta n by beta p decreases, this transition will shift from left side to right side as shown in this graph. So we can say the threshold voltage varies as beta n by beta p ratio decreases. So here the threshold voltage is dependent upon the ratio beta n by beta p. Here you need to note that even with the shift towards right side, the output voltage transition remains sharp, which means the switching performance is not affected, which is a big advantage in a CMOS VLSI design. Now let us understand adjusting beta n by beta p ratio through channel dimensions. During semiconductor fabrication process, we can modify beta n by beta p by adjusting channel length and width of a given transistor. So here you need to remember the parameter beta is directly proportional to W by L. So by adjusting these dimensions, you can balance the design. So during the fabrication process, we can modify beta n by beta p by adjusting the channel length and channel width. So here you need to remember the parameter beta is directly proportional to W by L. So by adjusting the width and length, we can vary the parameter beta that will balance the design. A balanced design is often desirable at beta n by beta p is equal to 1. This design ensures that a capacitive load charges and discharges in equal time interval, which will give the inverter equal current source and sink capability. It is like making both PMOS, which will act as pull up, and NMOS, which will act as pull down, work together. So the balanced design is often desirable at beta n by beta p ratio is equal to 1. So this ensures that the capacitive load charges and discharges in equal time interval. So if we say in equal time interval, which means in an inverter, there will be equal current sourcing capability. So if we say equal current sourcing capability, which means PMOS and NMOS will work together in harmony. Now let us understand how the temperature affects these characteristics. If temperature varies, this will affect carrier mobility in MOS transistors, which in turn affects beta. As temperature increases, beta decreases. So here beta is directly proportional to T to the power of minus 3 by 2. Since the current IDS is directly dependent upon beta, we can say IDS is also directly proportional to T to the power of minus 3 by 2. Here, both electrons and holes mobility are affected similarly. Therefore, the ratio beta n by beta p will remain constant. However, the threshold voltage, both VTP and VTN, decreases with temperature. This will affect the voltage transfer characteristics, which will cause the transition region to shift. So here, as temperature varies, this will affect the carrier mobility in MOS transistors, which in turn affect beta. As temperature increases, the beta value decreases. Here, beta is directly proportional to T to the power of minus 3 by 2. Since IDS is directly proportional to beta, the current IDS is also directly proportional to T to the power of minus 3 by 2. Here, you need to remember both electrons and holes mobility are affected similarly. That's why the ratio beta n by beta p will remain constant. The threshold voltage VTP and VTN decreases with temperature. So this will affect voltage transfer characteristics, causing the transition region to shift. So we can say the overall transfer curve will shift towards left side as temperature increases. For example, if temperature rise by 50 degrees centigrade, the threshold voltage decreases approximately by 200 millivolt. That will lead to 0.4 volt shift in input threshold. So in this lecture, we understood that the ratio beta n by beta p will influence the position of transition region in voltage transfer characteristics of CMOS inverter. But here, the switching will not be affected. Temperature variation causes a leftward shift in VTC due to reduced threshold voltage. Even though these variation exist, the ratio beta n by beta p remains constant. This is about influence of beta n by beta p ratio on transfer characteristics. Understanding these concepts is crucial for designing reliable CMOS circuits by adjusting beta n by beta p ratio and accounting for temperature effect. Engineers can optimize the inverter performance for various applications.